Hi friends, Dr. Jim Daly here. We here at Astronomy for Change, part of our mission is to effect positive change through astronomy and science education by inspiring and empowering current and future generations to become engaged and interested in astronomy and science. Part of our mission is community outreach, training and assistance for primary schools, etc. Okay, so a big aspect of our mission is education. So as an educator, as professionals, we have an obligation, a responsibility to the greater society at large, to the world at large, to educate in science and education when we see it is necessary. Okay, such a development has come up now, where we have to add our voice to something that's we see as a threat to the Earth, to the human race as a species, and to the biosphere in general. Okay, the Amazon rainforest is literally on fire. You can say it differently: the planet is literally on fire. What we want to do today in this video is to just talk about the science of what's happening here without talking about the politics. That's a discussion for a completely different forum, a different genre entirely. And it's a whole different set of, it's a whole different conversation, whole different set of discussions that we could have about that. Right now, we just want to talk about the science, what's happening and what needs to happen to mitigate this and to basically minimize the damage to the planet, to the environment, and to the biosphere, the very delicate, fragile sphere of life. Sphere is a metaphor that resides within only a few kilometers of the surface of the Earth. That's what we call the biosphere, and that's under direct threat today. That's manifested by the fires that are taking place in the Amazon rainforest. Okay. Whether or not these fires were deliberately set is a debate that we can have again in another forum, at another time, in another conversation. Be that as it may, climate change, or the change in the amount of CO2 in the atmosphere, has a direct effect on the hydration and the amount of water and the entire dynamic involved, the water cycle, the interplay between evaporation, sunlight, and absorption in the plant. The whole dynamic in play here is being affected by elevated levels of CO2. Okay, so how is climate, the change in the amount of CO2 in the atmosphere, how is that affecting the rainforest? Okay, if the amount of CO2 entering the atmosphere, the CO2, first of all, is a greenhouse gas. Okay, what does that mean? The sunlight coming into the atmosphere is mostly visible light. When it strikes the surface of the planet, this is not a mysterious thing. This isn't rocket science. This is basic science. As the sunlight, most of the sun's energy is radiated in the form of visible light. The sun is it's modeled as an object that's about 6,000 degrees Kelvin. An object with that heat and that temperature will radiate energy, most of the energy, in the visible part of the electromagnetic spectrum. Okay, so that visible energy, that visible light, strikes the Earth's atmosphere, comes through the atmosphere, mostly unattenuated, and strikes the surface of the Earth. Okay, most of the energy we receive at the surface of the Earth from the sun is in the form of visible light, not heat nor anything else, in the form of visible light. So what happens? The ground absorbs that energy. It's energy, right? So the ground absorbs that energy and re-radiates it in the form of infrared energy, heat. Well, the dynamics regarding the atmosphere, the atmosphere has trace amounts of CO2, has 78% nitrogen and 20% or so oxygen. That concentration and water vapor too. Those concentrations, there's a certain dynamic in play before the Industrial Revolution, where we had no CO2 being emitted into the atmosphere, there was a certain balance, an interplay, a dynamic between the ecosystem, the amount of energy coming from the sun, the seasonal changes in temperature, etc. That was all in balance. Now, with the introduction of extra CO2 in the atmosphere, we are experiencing atmospheric heating, okay, by burning carbon-based fuels. The combustion of carbon-based fuels uses oxygen, okay, it's combustion. So you're going to use oxygen as part of the chemical equation. The oxygen comes in with a fuel, and when you ignite it, it burns. The output from that is a lot of its hydrocarbons and a lot of its CO2. The CO2 is a greenhouse gas, which means what? It means it traps that heat energy that was radiated away from the surface of the planet. Okay? The more CO2 you put into the atmosphere, the greater the amount of heat that gets trapped in the canopy of the atmosphere. Consider it as a greenhouse. The name greenhouse was named as such for precisely what it's doing. The sun's visible energy comes in, strikes the ground inside, and the heat stays trapped inside that greenhouse to give warmth, light, heat to the plants inside. Okay. Most of the energy the sun radiates is in the form of visible light. The Earth's atmosphere is transparent to visible light, but partially opaque to infrared light. Sunlight is mostly visible energy, and when it strikes the surface of the Earth, it is re-radiated as infrared energy, which is then partially trapped by the CO2, water vapor, and methane in the atmosphere, all greenhouse gases. This is known as the greenhouse effect and has been exacerbated over the previous 150 years since the beginning of the Industrial Revolution through the continual and increasing addition of CO2 and thus the delicate balance between insolation, the incoming energy from the sun, absorption, reflection, and re-radiation being destroyed. Okay, so with the extra CO2, the planet is warming. The ice caps are melting and so forth. So why is the Amazon rainforest? Why do we have fires? Well, the extra warming, most of the extra heat is absorbed by the sea. We feel it in the atmosphere, but most of the energy that's being trapped near the Earth's surface is getting trapped in the sea. So as the seawater warms, the rain cycle changes in areas like the Amazon rainforest. Now, if we take a look here, okay, we have 48 active fires within 48 hours. Just the other day, August 22nd, 2,500 fires are now active in the Brazilian rainforest. Okay, so getting back to our original question, what's causing the fires? Okay, this is an infrared map of the fires as of today. Okay, for the month of August, 2019-08, Amazon fires as seen from space. This is an infrared map, so when you're looking down on the continent, the South American continent, you see these red areas as fires. That's where heat is coming from. Okay, so the warming sea in the regions near the coast, okay, cause the evaporation and the rain, that whole interplay, that whole dynamic changes as the sea temperature rises. The sea, as we just said a few minutes ago, is on the receiving end of a lot of the trapped heat from the extra CO2. And I also should point out at this point, CO2 can be considered a precursor gas to the main event. Okay, CO2 is, yes, it's a greenhouse gas along with H2O, which is water vapor. The big danger is the release of significant amounts of methane. Methane is 20 times more efficient than CO2 as a greenhouse gas. Now, a lot of the activities to extract natural gas from underneath the surface of the Earth in the form of fracking leads to emissions in methane gas. That methane, if that methane continues to be released at the rate it's going, CO2 will be nothing compared to the nightmare scenario we would face. It would be irreversible. At some point, if the methane levels continue to rise. So CO2 in this case, in this scenario right now, CO2 is a precursor gas. It's a catalyst to the main event. So we have to prevent at all costs from additional release of methane gas. Okay, so getting back to the Amazon rainforest, the process of photosynthesis, where the sun's energy is absorbed by plants, right, using existing carbon dioxide in the environment along with water, in a process known as photosynthesis. Photosynthesis is a chemical process. All chemical processes require energy. The energy is obtained from the sunlight. Okay, so the plant takes in has carbon dioxide, breathes in carbon dioxide and water, along with the energy from the sun, internally produces carbohydrates for its continued growth and survival, and as a waste gas emits oxygen, as can be seen in this diagram here. Okay. This is a different diagram, illustrates it pretty much in the same way. It's a cycle. The CO2 comes in through photosynthesis and sunlight, mostly solar ultraviolet. The process of photosynthesis produces oxygen. Now, in the case of the Brazilian rainforest, 20% of the world's oxygen is produced in the Amazon rainforest. So, in a metaphoric way, as a metaphor, we can quite literally say that we are choking the biosphere, the planet, from breathing. Okay, we are basically directly targeting the lungs of the planet. And there's been metaphors, and it's not quite a metaphor, it's actually almost literally true, that the Amazon rainforest are the lungs of the planet, and we have to stop burning. We have to leave the rainforest alone. Whatever the geopolitical reasons, the economic reasons for the deforestation and the burning in the rainforest, whatever those reasons are, it's not a topic that we're going to be discussing here. That's, again, as we said, that's a topic for another forum and another conversation, but it has to stop because we're literally destroying our ability to breathe. Okay, so getting back to what we were just talking about, the process of photosynthesis, along with that, as a parallel process, we have this process known as evapotranspiration, where evaporated water from the leaves of trees rises into altitude, cools at a higher altitude, condenses, forms clouds, and rains. That whole process is now being interrupted by the warming sea level and the warming environment. This process is being mitigated, or in some cases completely reduced. So the transpiration is being reduced, and thus causing a drought. The ground dries out, the trees die, and we have natural deforestation, natural in the sense that it's not a man-made, we're not deliberately deforesting the area. In some cases they're logging, they're clear-cutting whole swaths. I think at the last news report I saw was 20% of the rainforest has already been clear-cut. That has to stop. Okay, so we're literally cutting off our oxygen supply. If this doesn't stop, this has to stop. Okay, the evaporation from the leaves, the water vapor, most of the water vapor is evaporated away into the atmosphere, rises to altitude, condenses, forms clouds, and rains. Right? Okay, so that dynamic, that interplay between rainfall, absorption by the plant, photosynthesis, that whole dynamic is now being interrupted because of the warming sea temperature and the warming atmosphere. Okay. All right. So here's the chemical process right here. You take in 6 carbon dioxides, you add water vapor, the energy from the sun, sugar in the form of glucose, and oxygen is produced, right? So this is the photosynthetic process right here. All right. Whether or not the clear cutting has definitely been ongoing. I mean, that's a documented fact. The economic reasons, the geopolitical reasons, or the whatever other forces are driving this, they need to be stopped and mitigated. We're literally cutting off the planet's oxygen supply. Okay, folks. This is a very important topic, and as always, here at Astronomy for Change, if you don't understand some aspect of this discussion, please leave a question in the comment section below. If you found this video educational and helpful, please do like and share and subscribe to our channel. The public website is a separate subscription than the YouTube site. So please like and subscribe to both, and share this story, share the science. The one way we can help all of us is to share the science, tell people, get excited about it, get inspired about it, and say, discuss it in a positive sense, not in a negative sense. Okay, we have to be good stewards of the planet. It's our responsibility to pass on a clean environment, a healthy environment to the future generations. That's on us. We have to take care of that. Okay? Another aspect to this this real world crisis that we're now facing. This is climate change, and what's happening in the environment is an existential threat to the species, to the planet. Well, the planet will survive, but to life itself, this is an existential threat, and we have to find a solution to this. Okay, it's one thing to develop sustainable energy solutions like windmills, solar panels, geothermal energy, things like that. Nuclear power is a good one. Okay, there's a zero carbon footprint with nuclear power. Problem is finding a workable solution to dispose of the nuclear waste. That's a separate issue. But the nuclear power station, the technology is mature, and it produces zero carbon footprint, so which is good. All these solutions to produce energy and provide us with a sustainable, reliable energy source for civilization and for the world as we know it today, that's fine. Okay, if we were to cut our emissions today, right now, it would take 150 years for the amount of CO2 already in the atmosphere to mitigate away through attrition and through natural attenuation and consumption by the plants. It would take 150 years from now, today, if we just turned all the CO2 burning off, all fossil fuel burning off right now, right today. If that was stopped today, it would take 150 years. Okay, that's not going to happen. So what we have to do is find a solution to remove the existing CO2 from the atmosphere and thus give the planet a chance to breathe and allow the natural processes to take back over and to cleanse the air. The one big thing we can do is to literally go plant a tree. Lots of them, and lots of them, lots of trees. Planting lots of trees will take the CO2 that's in the atmosphere now and allow the planet to resume breathing the way it used to breathe before the Industrial Revolution. Take in the CO2, produce oxygen. Okay? Planting trees is a great idea. It helps the environment, produces natural shade, and it's aesthetically pleasing, and it's just the right thing to do. Finding sustainable energy solutions is fine, and we have to keep doing that. But we also have to find a way to remove the CO2 from the atmosphere. The one way to do that is to plant lots of trees. Go plant a tree is what we should be doing. Okay, everybody. Again, please leave your comments and suggestions in the comment section below. Do like, share, and subscribe. And please, we look forward to your continued support here at Astronomy.